The sun's annual path across the celestial sphere is a great circle called ecliptic. The ecliptic plane is tilted relative to the celestial equator by 23 degrees. At equinox points, the sun crosses the equator, moving from one hemisphere to another. The ecliptic coordinate system is essential for calculating orbits of bodies in the universe.
If you've ever watched the sun move across the sky, you know it doesn't stay in one spot. But what you might not know is that it follows a very specific, invisible highway through the stars every single year. That path is called the ecliptic, and understanding it is absolutely fundamental. It's the key to our seasons, to our calendar, and to how we map the entire solar system. So let's trace that celestial journey.
Here's the plan for our discussion today. First, we're going to look at how we even figured out the sun's annual path in the first place. Then, we'll get a solid definition of what the ecliptic is and identify its most important landmarks. From there, we'll see how this path creates its own unique coordinate system, and finally, we'll wrap up by exploring why this system is so critical for astronomers. So let's start at the very beginning, with observation. For thousands of years, people noticed that as the Earth's seasons changed, the sun seemed to drift against the fixed background of the stars. This wasn't a random wobble. It was a predictable, repeating pattern. The big question became, how do we actually map this journey? How can we chart this celestial pattern with any precision?
Well, by tracking the sun's position every day, you can actually plot its coordinates, just like points on a map. Think of it as celestial latitude and longitude. We see its declination, which is its north-south position, swing from about 23.5 degrees north down to 23.5 degrees south. At the same time, its right ascension, or its east-west position, drifts steadily eastward, making a full 360-degree loop over the course of a year. It's this continuous, predictable movement that we want to understand.
Now, to make sense of all this motion, astronomers came up with an absolutely brilliant conceptual tool, the celestial sphere. Just imagine a gigantic, hollow globe, with the Earth sitting perfectly in the center. All the stars, the sun, the planets, they're all projected onto the inner surface of this sphere. Now, if you take Earth's own equator and expand it outward like a disk until it touches the inside of this sphere, you create a fundamental reference line called the celestial equator. This becomes our 0-degree baseline for the entire sky.
Okay, so we have this clear path that the sun traces across our imaginary celestial sphere year in and year out. It's time to give this solar highway its proper scientific name, the ecliptic.
Put simply, the ecliptic is the great circle that the sun appears to draw on the celestial sphere over the course of 1 year. It's this grand loop that takes the sun through the constellations of the zodiac. You know, if you could somehow just turn down the sun's glare and see the stars behind it, you'd watch it slowly, day by day, trace this exact line. And here we arrive at the single most important concept of this entire discussion. The ecliptic and the celestial equator are not the same line. They are tilted relative to each other. As you can see, this angle of inclination, which we call epsilon, is approximately 23.5 degrees. And this one fact, this simple tilt, is the reason we have seasons here on Earth. It's that critical. Now, just like Earth's rotation defines our familiar north and south celestial poles, this tilted ecliptic plane defines its own set of poles. Imagine drawing a line straight through the center of the ecliptic plane, perpendicular to it. Where that line pokes through our celestial sphere, we get the north and south ecliptic poles. Now, it's really important not to confuse these with the celestial poles. They're two different sets of poles based on two different fundamental planes. So, because these two great circles, the ecliptic and the celestial equator, are tilted, they have to intersect. And where they intersect, and where they are farthest apart, we get 4 incredibly important points along the sun's yearly path. These are the celestial landmarks that define our seasons. Imagine you have 2 giant hula hoops, one inside the other and tilted. They're going to cross each other at 2 points, right, on opposite sides. It's exactly the same with the ecliptic and the celestial equator. These 2 crossing points are the equinoxes. When the sun crosses the celestial equator on its way north, we call that the vernal or spring equinox. And 6 months later, when it crosses that same line heading south, that's the autumnal equinox. And what about the points between those intersections? The points where the sun reaches its maximum distance from the celestial equator? Those are the solstices. The summer solstice is the point where the sun is highest and most northerly in the sky for the year. And the winter solstice is its lowest, most southerly point. These 4 points together, the 2 equinoxes and the 2 solstices, mark the official start of our 4 seasons.
All right, so now that we've defined this new fundamental plane in the sky, the ecliptic, we can do something really useful with it. We can actually build an entire coordinate system around it. This gives us a completely different way to map the positions of objects, one that's totally separate from the standard equatorial system. This new system, unsurprisingly, uses two main coordinates to locate any object in the sky: ecliptic latitude, which we denote with the Greek letter beta, and ecliptic longitude, which gets the letter lambda. So let's break down exactly what each of these means. Ecliptic latitude, or beta, is actually pretty simple. It's just a measure of how far an object is above or below the ecliptic plane. Just like latitude on an Earth map tells you how far you are from the equator, ecliptic latitude tells you an object's angular distance from the ecliptic. A positive value means it's north of the ecliptic, a negative value means it's south. Ecliptic longitude, or lambda, then measures an object's position along the ecliptic circle itself. And just like longitude on Earth needs a starting point, the prime meridian in Greenwich, ecliptic longitude needs one too. Our starting point, our 0 degrees, is the vernal equinox. From that point, we just measure eastward all the way around the circle, from 0 to 360 degrees.
So you might be asking yourself, okay, why do we even need this? We already have a perfectly good coordinate system based on the celestial equator. Why go through all the trouble of creating a second one? Well, it turns out the ecliptic system is absolutely indispensable for one very specific job.
The ecliptic coordinate system is the absolute go-to for anyone working in celestial mechanics, for anyone trying to map the motions of things in our solar system. And the reason is beautifully simple. Almost all the planets, from Mercury all the way out to Neptune, orbit the Sun on roughly the same flat plane. And guess what that plane is? It's the ecliptic. So if you're tracking a planet, its ecliptic latitude, its distance above or below that plane, is always going to be a very, very small number. This makes all the calculations for predicting the orbits of planets, asteroids, and comets much, much simpler.
Let's finish with a quick thought experiment to tie all of this together. Just imagine for a moment that Earth's axis had no tilt. What if it pointed straight up and down as it orbited the Sun? What would the ecliptic look like then? Well, in that case, the celestial equator and the ecliptic would be the exact same line in the sky. They would perfectly overlap. The Sun would travel along the celestial equator all year, there would be no solstices, and there would be no seasons. It's a powerful reminder that this entire elegant concept and the rhythm of life on Earth it creates all comes down to that one simple, crucial 23.5-degree tilt.
Thank you, friends. Strive for understanding and become wiser. See you soon.